Hello and welcome to another video on probabilities. Today we're going to be looking at marginal probabilities. So let's start by this example here. Small cars getting better gas mileage, but they are not as safe as bigger cars. Small cars account for about 18% of the vehicles on the road, but accidents involving small cars led to 11,898 fatalities during the recent year. Assume the probability a small car is involved in an accident is 0.18. The probability of an accident involving a small car leading to a fatality is 0.128, and the probability of an accident not involving a small car leading to a fatality is 0.05. Suppose you learn of an accident involving a fatality. What is the probability a small car was involved? Assume that the likelihood of getting into an accident is independent of car size. So let's take a look at the probabilities here. Again, as we mentioned, the probability of being a small car involved in an accident is 0.18. The probability of a fatal crash given the car is small is 0.128. And the probability of a fatal accident given the vehicle is bigger is 0.05. So let's try to determine what's the probability of a bigger car. Well, we know what the probability is of a small car. So to be able, that's 18% of the cars. So if we were to take 100% of all vehicles and subtract out the percentage of small cars, we would get the probability that they were bigger. So that simply equals 1 minus the 0.18. So there we have it. So 0.82 or 82% of the cars are bigger vehicles. So what's the probability that a accident contains a small car and it's fatal? This one is simply, we want to take the probability that it's a small car involved in an accident, that's 0.18, and we want to multiply it by the probability that the accident contained a small car and was fatal, which was 0.128. So we simply take equals the 0.18, the probability being small, times the probability of it being fatal given a small vehicle is involved, or this one, 0.0230. Now let's look at the probability that's a bigger vehicle and fatal. So now we simply take the equals. We want to take the probability that it's a bigger vehicle, and we want to times it by the probability that it's a fatal accident given that a bigger vehicle is involved. So H12 times H11. Now we know it's 4% probability that it was a bigger vehicle and a fatal crash. Next, we want to determine the probability of it just being fatal, period. So to do this, we just take equals the probability of it being small, vehicle involved in a fatal accident, plus the probability of it being a bigger vehicle involved in a fatal accident, 0.064. And finally, we're going to take a look at what's the probability that it was a small vehicle given it was a fatal crash. This one's a little trickier. To do this, we simply want to take equals the probability that it's a small car involved in an accident times the probability it was a small vehicle involved in a fatal accident. Then we want to go ahead and divide this, and we want to close this in parentheses. The probability of it being a small vehicle times the probability of a small vehicle involved in a fatal crash plus the probability of it being a bigger vehicle times the probability it was a fatal crash given it was a bigger vehicle. You see how that works? So we're simply taking both the probability of being small and fatal and adding the probability it was bigger and fatal. Okay, close the parentheses and we enter. So your answer is 35.98% that the probability of a small vehicle involved in a crash is fatal. Okay. We're going to take it another step further here. Now we're going to look at the American Council of Education. They reported that 47% of college freshmen earn a degree and graduate within 5 years. Assume that graduation records show that women make up 50% of the students who graduated within 5 years, but only 45% of the students who did not graduate within 5 years. The students who had not graduated within 5 years either dropped out or were still working on their degrees. So here we go. We're going to go ahead and spell this out. Students earning a degree and graduate within 5 years, 47%. Female students graduating within 5 years, 50%. And finally, percentage of students who are women and did not graduate within 5 years, 45%. That was all given up here. Now let's say we're being asked to assess the students that graduated within 5 years. We can determine whether they're female and graduated within, or more than 5 years mean female. Same thing for male on graduating within 5 and not graduating within 5. So the first thing we want to do is let's look at the first cell here. Now this is an event. A1 is the event, and the event is graduated within 5 years. Okay? So we want to say equals, we have 47% of the people graduating, so we'll click that one, and we want to multiply that by the probability of a female graduating within 5 years, or 50%. And we hit enter on that one. So we have 23.5% graduating within 5 years are female. Now let's look at the men. So let's go ahead and say we know it's 47% and 23.5 are female. So we simply do this, equals the total percentage of 47% and subtract out the percentage that were women. And now we have 23.5% left over were men. So we have an equal distribution here of 23.5% graduating within 5 years were female, 23.5% graduating within 5 years are male. So now let's look at the event of A2, which is the event of somebody not graduating within 5 years. The first thing we want to do is we actually know that 47% either graduate within 5 years, so we need to be able to determine how many didn't graduate within 5 years. We simply take equals 1 minus the 47%. That says, okay, now we have 100%. So we have 47 plus 53, that counts for the entire population. So now to be able to determine the percentage of females who did not graduate within 5 years, we say equals, we know that the percentage of students who are women did not graduate within 5 years is 45, but then we want to go ahead and times it by the percentage. And now we have 23.85% is the marginal probability. We want to do the same thing for men. Now this one is as simple as this one here. All we do is equals, we know the total percentage, and we want to subtract out those that are female to get what's left over for male. It can only be two possibilities, right? You can only be female or you can only be male. All right, now we're going to look at using the given information. What are the values for the probability of event for A1, the probability for event A2. Now let's look at the next one, the probability that there are women who graduated for event A1, which is within 5 years, or the probability that women who graduated for event 2, which was greater than 5 years. So looking at the probability, we already know these answers, right? So we say the probability of event A equals J30, 47%. That's the probability event of A1. Okay. Now the probability of event A2 is 53%, right? Now we want to take a look at the probability that it's a woman who graduates within event A1. Again, we know this, and we need to know this to be able to calculate our next set of formulas here. So equals J28 here. And the same thing for men. Equals the probability of event A being male. There we go. All right. Now we want to look at what is the probability that a female student will graduate within 5 years. What is the probability that a female student will not graduate within 5 years? So now we know these numbers here. Okay? So probability of event A, given that they're woman, is equals the probability that they're female in event A1 and divided by the probability that they're female across the board, which is 47.35% of the population that we're looking at. Okay? So there you go. So the probability of event A1, which is graduating within 5 years, given they're woman, is simply taking the probability that they're female in the event divided by the total percentage of females out of the population. So 0.4963. We want to do the same thing. What's the probability for event A2? Equals the 23.85 and divided by the total percentage of the women out of the population. And notice how it equals 1. So they either graduated within 5 years or they graduated not within 5 years. What is the probability that a student is male and will graduate within 5 years? The same calculation can be used on this one, right? So we know the probability that they're male, sorry, don't mean to scroll around here, equals J29, which is 23.5, just like the females, right? And now what's the probability that they're male? We know that number, all right? What is the probability that a male student will graduate within 5 years? So what is the probability that the male student will not graduate within 5 years? So again, just like we did for the females here, it's simply taking the equals, the percentage chance that they'll graduate within 5 years, and we want to divide it by the total percentage of males out of the population, 0.4463. Same thing for not within 5 years, and divided by the total population. And again, this equals 1. So we have 44% of males will graduate within 5, and 55 will graduate more than 5. So what is the percentage of women and men entering into the freshman class? So we simply take the percentage that they're women equals, we know they're 47.35, and now the percentage that they're male equals 52.65. Okay, so now we have a calculation that says 1, because we notice that 47% are female, 52 or 53% rounded would be male. It's 100% of the population. Now let's look at what is the probability that a student was female given that the student graduated within 5 years. Now, this one's a little bit trickier, okay? On this one here, and hopefully we can see the screen here, I need to scroll up a little bit, equals the probability that they graduate within 5 years. We want to divide that by, open parentheses, the probability that they're female plus male, okay, close the parentheses, and there we go, 50%. What is the probability that a student was female given that the student graduated in 5 years? And this makes sense, right? Because we can just briefly look at this. 23%, 23%. Well, if this encompasses all the people who graduate within 5 years, and since they're equal, we would expect them to be 50% female, 50% male. It's an equal distribution here. Okay. And finally, what is the probability that a student was female given that the student did not graduate within 5 years? This one's as similar as this one. So we say equals. Now we want to take K28, which is the probability that they didn't graduate within 5 years and they're female. And we want to divide that by, open parentheses, the probability they can graduate plus the probability of this one. Close the parentheses, and there we go. 45%. Well, that's just a brief overview of how we look at probabilities and why we look at these. Thank you for watching.